Hello, designers. Have you ever designed a flawless interface only for a user to break it in seconds? Maybe they entered an emoji in a form field, used your app in airplane mode, or tried to sign up with a blank email address. These are edge cases, rare, unexpected user behaviors that can completely derail a digital experience. Most UX designers focus on the happy path, the ideal flow where everything works perfectly. But real users don't always behave ideally. They run into errors, push system limits, and find loopholes in your design. If we don't prepare for these scenarios, our products will fail when users need them most. In this session, we're going beyond perfect UIs to talk about designing for the unexpected. Because a truly great experience isn't just smooth when things go right, it's resilient when things go wrong. What I will cover in this session: what are edge cases, categories, and examples? How to anticipate and design for edge cases. How game designers tackle edge cases and what UX can learn. Research insights on error prevention and UX resilience. Let's get started. What is an edge case? There are two types of cases: the general case, which is the most common user journey, and the edge cases, that is uncommon, boundary conditions that can break the system. An edge case happens when a user goes beyond expected input. For example, a user entering a 300 character name in a form, or uses the product in extreme conditions like slow internet, no battery, one handed mode. It can also happen when there is an unexpected loophole. For example, a user using an emoji as a username. Why does this matter for better experience? A well designed experience is not just usable when things go right, but resilient when things go wrong. Here are some examples of catastrophic edge case. Imagine you're designing a flight booking app. Everything looks perfect. But then, a user tries to book two flights for the same time. System crash. A user enters their name as random characters. Validation error. The user is halfway through booking when their internet disconnects. Data loss. If these scenarios weren't considered, the product fails, leaving users stranded and frustrated. So, what are the common types of edge cases? Edge cases aren't just random glitches, they fall into clear categories. First is technical edge cases. These happen when technology doesn't cooperate, for example, no internet or a slow connection, app session expires, or data gets lost, uploading a huge or broken file, low battery mode affecting app performance. Instagram doesn't fail when your internet is bad. Instead, it saves your post and uploads it later. Smart, right? Second is user input edge cases. Users do all kinds of unexpected things: typing super long names or just one letter, adding emojis, symbols, or extra spaces, copy pasting weird text formats, leaving forms blank and still trying to submit. When Twitter allowed custom display names, people filled them with emojis, which broke the UI. They later had to add limits. Third is accessibility and inclusivity edge cases. Not everyone uses apps the same way. Some people rely on screen readers or voice commands. Others have vision or motor impairments. Even left handed versus right handed usage matters. Google Maps has voice navigation so blind users can get directions without needing to see the screen. Fourth is cultural and localization edge cases. What works in one country might not make sense in another. Words take up different space in different languages. Symbols can mean different things worldwide. Date, time, and currency formats vary. Twitter once used a quill icon for writing tweets, but people in Japan didn't get it. They replaced it with a simple tweet button. Fifth is security and malicious user edge cases. Not all users have good intentions. Spammers, filling forms with fake data, trolls abusing reporting features, bots trying to hack accounts. Airbnb uses AI to catch fake names and stolen profile photos to keep things secure. How to anticipate and design for edge cases. That is, designing for the 99% is easy. Designing for the 1% is what makes a product great. Step 1: Spot edge cases early. Don't wait for users to complain. Catch issues before they happen. Talk to developers. They've seen all kinds of failures. Test with extreme users. Try both power users and first time users. Ask what could go wrong at every step. You'd be surprised at the answers. Step 2. Make errors less painful. Mistakes happen. The goal? Help users recover quickly. Show clear, helpful error messages. No confusing tech jargon. Let users undo mistakes. Don't make them start over. Offer autosave and retry options so progress isn't lost. For example, ever notice how Gmail warns you if you forget to attach a file? That's smart error handling. Step 3. Design for flexibility. Not all users behave the same way. Your UI should adapt, accept different input formats, dates, phone numbers, addresses. Handle short and long names properly. Not everyone is John Doe. Support extreme screen sizes, from tiny smartwatches to giant monitors. An example for this is Google Forms lets you paste in a messy date format and still figures it out. That's flexibility done right. Why this matters? Research backs it up. Studies show that ignoring edge cases can seriously hurt user experience. Users abandon products 4 times faster when edge cases aren't handled well. Clear error messages boost user recovery by 70%. Proactively designing for edge cases can cut support tickets by 35%. Bottom line here is design for the 1%. If you think about rare scenarios, your product will feel seamless for everyone, no matter what weird situation they run into. And trust me, users will notice. Here are many lessons that we can learn from game design and how games handle edge cases. First is always provide a backup, n plus 1 fallback. Game designers ensure that if a critical element fails, example a character dies or an event is missed, the system provides an alternative path to maintain progress. Here are some examples in UX application. Google Docs. Autosaves work. Even if the browser crashes, documents are never lost. E-commerce checkout flows allow users to recover abandoned carts or retry failed payments. Second is prioritize flexible, system-driven design. Instead of rigid, linear pathways, games use adaptive mechanics to account for user choices. This ensures multiple ways to achieve an objective. Some examples are as following: Airbnb dynamically adjusts listings based on availability, user behavior, and policy changes, rather than relying on fixed user journeys. Navigation apps offer alternate routes when a preferred path is blocked. Third is anticipate and handle unexpected inputs. Games allow players to interact freely, which means unexpected actions must be accounted for. Instead of blocking users, games provide adaptive responses. For example, Payment Gateway API doesn't just fail when a card is declined, it suggests alternative payment methods dynamically. Online form validation accounts for varied name formats, special characters, and cultural differences rather than enforcing rigid structures. And last but not the least is design for power users and extreme cases games undergo early access testing, where dedicated players attempt to break the system. This stress testing approach helps identify weak points before launch. OTT apps ensure smooth playback even on slow connections, dynamically adjusting stream quality rather than failing outright. Accessibility testing ensures products work for users with disabilities, preventing exclusion due to overlooked design issues. Some case studies on how leading companies handle edge cases. E-commerce, handling payment failures. Problem: users with expired credit cards abandon their carts. Solution: system notifies users before expiration and suggests updating payment info before checkout fails. Another example is cab services, handling ride cancellations. Problem: riders cancel trips last minute, frustrating drivers. Solution: charges cancellation fees, but also allows quick rebooking to minimize disruption. Some of the best practices for designers are design for failure, not just success. Every interaction should have a what if it fails scenario. Use progressive disclosure, show complex options only when needed. Think about the worst case scenario. If it breaks, how does the user recover? Before I wrap up, here are the final thoughts on why edge cases define great UX. Great design isn't just about making things beautiful, it's about making them resilient. If we ignore edge cases, we create experiences that fail when users need them most. So, next time when you're designing, ask yourself, what happens when something goes wrong? How does the system recover? What's the worst possible input a user could enter? By planning for the unexpected, we make products stronger, more inclusive, and truly user friendly. That's it for now. See you in the next video.